Alright, to graph a piecewise function, you graph it in pieces, obviously. So this is one piece, and this is the other piece. The key is to look closely at the domain. What this is saying is that these values, like the pieces, go for part of all the way from negative infinity all the way to -1, and then this happens from -1 to the positive side. So I always suggest to put in the tiebreaker, the location that is used by both values. And the first one also is anything, smaller. So I don't know, I'll just use -3. The other one implies things that are bigger than -1. I like 0 because it's quite simple. So I am going to put in 3 times -1 plus 5. This is 3 and 5 makes 8. And then I'll put in the -3, so -3 times -3 plus 5. This is 9 and 5 is 14. So one of the things I want you to notice too is that this is the values that are smaller than or equal to -1. Which means at -1 and 8, I'm going to create an open dot. And then at -3 and 14, now that's off my graph, so that's a little tricky. -3 and 14's up here somewhere. I'm going to create my graph heading off in that direction. I also want to find what's going on in this value here. So I'm going to plug that into the equation. 2 times -1 minus 1. It's -2 and -1's -3. So the other function is at -1, -3, and it includes that location because of the equals sign there. I'm also going to plug in 0. 2 times 0 minus 1 is -1. So at 0, it's -1. I notice that it's heading off in this direction. To see how I'm able to, I calculate the one group. How do I know what values to use for my inputs, my x values? They all have to be less than -1. But you always want to use the breakpoint. You want to use that value, and you might end up putting the open dot there. And then in the other case, also use the -1, but in that case you put the closed dot, and then the next one moved along, and you get your two pieces in the piecewise function.